Thank you very much. Right, so what I'm presenting today is just one part of a really broad study. So I'm going to try to focus it and make it interesting for everyone here. So the background for this work is that actually hedonic pricing modeling of the property market is a very useful tool for policy. You're probably all aware of that. And it can be applied to a very wide range of areas, market valuation, appraisal, specific items like value capture, and so on. And here I'm basically focusing more on the area of valuation, trying to understand the relative values of certain goods, accessibility, for instance, or other non-market goods. Now, why this is important? It can be a really powerful tool, but it's not really that widely applied in practice for policy purposes compared to other valuation techniques. But it's really powerful first because it's observed behavior. It represents long-term choices as opposed to more short-term ones reflected in stated choice experiments. It can also include at the same time a lot of really different policy variables, not only in transport but in general, things to do with education, environment, and so on. But however, that doesn't seem to be, this is the sort of main motivation for this part of the study, there doesn't seem to be a consensus around how you specify a hedonic price modeling, which variables you include, and which model to recommend basically for policy purposes. For various reasons that we argue in this paper. First, the theory is not strong enough as to sort of lead the model specification, as in other fields. There's a sort of lack of trust in basic OLS models, also for well-justified reasons in some cases. But at the same time, more advanced models and now new spatial econometric techniques being applied to hedonic pricing are also sometimes difficult to interpret for policymakers and difficult to give this economic justification underlying. So, altogether, we think that there is some merit in revisiting and looking back again to what's the underlying economic theory and how you actually specify a hedonic price model if, which is our purpose here, is to understand the value of better accessibility to jobs in a given context. So what we do here is we say we think there's three limitations of hedonic pricing currently. One is little guidance on how economic theory should shape the model. Second, model comparisons of main types, OLS versus spatial lag model, spatial error model, are based on what we think are limited data set. Most hedonic pricing studies, although there are tons of them, are based on one city. And actually, the policy questions, for instance, what is the value of accessibility at the national level or the regional level, can have a scope mismatch, to say, because if a study is focused on one city, it doesn't really allow you to understand the impact at the regional scale. So what we do is we propose a very simple conceptual framework, which partly is not really new, it's just drawing on what the underlying basic Rosen theory of hedonic pricing model says and how we can actually interpret that to specify a model, and then compare the three main type of models on this, what we think is quite unique, detailed, regional level data set built for purposes for one project. And we identify and discuss some of these key choices that I'd like to discuss with you all at the end of the presentation. So the wider study is about quantifying property value response to accessibility changes in the north of England. This is funded by Transport for the North and the West Yorkshire Combined Authority in the UK. And we were tasked with this job of building a really large hedonic price model for the whole region. For various reasons, but I'm not going to enter into that. So the theory, as I say, is not strongly shaping models at the moment. You see a lot of empirical papers with very little justification of why some variables are included or not, and some key ones like income. And so looking back to the theory, so it's sort of the basic is well developed there, that's all fine. Started with Rosen's work. And the presumption is basically housing units are described as a vector of objectively measured characteristics. Now this is good because even if you're not familiar with hedonic pricing nor market valuation, you all live somewhere, so you all at some moment have either bought a house or renting a place somewhere, so you understand what this means. This is why the property market contains so much information, because it has information on how people value loads of different things that are very important for policy. So one of the key things that Rosen says is that a property's value for its utility-bearing characteristics. So that's the first key message that we get from there. So if we define a property as a bundle of characteristics, the price of a property is the price of different components. Standard theorem, we're going into the equations, but it's all assumed that you can derive the relative valuation of every aspect of the property if the model is sort of well defined. So the key questions that we put forward to develop this basic conceptual framework, which some people will have already specified in some similar way, but nobody has really said, right, these are the key choices that you've got to make to build a model that is consistent. So first of all, what are the house characteristics that are utility bearing? Well, we define three broad categories. We start by saying, and we try to impose a logic chain for each of those. So the first one is the building and plot characteristics of the house, the property itself. Second, we got the place quality, so everything that is around the house could be more or less local to an extent, but including physical and social characteristics, like crime, for instance, or socio-demographic characteristics of the neighborhood. I mean, people tend to move to areas where they can live near people that are similar in different social scales. And that has an utility-bearing impact, we argue. And third, this area of economic opportunities and accessibility to jobs. So that is simple model. Additionally, we know that there are, prices are determined not only by demand and preference, but also by supply, and there are some supply aspects that you have to control for. So what are the other factors that we have to control? We say these sort of non-utility drivers are supply constraint, supply of properties in the area, and the time of the year, seasonality, and so on. So we think those are important factors as well to control for. Third key question is, what is the role of income? This was one of the ones puzzled me the most when I was reviewing the literature, because I saw some papers included it fine without much discussion, whereas others didn't, or say, right, you have an endogeneity problem, you cannot include it. Fine. So we thought, right, what's the role of income for a hedonic price model? So we first obviously has this role of household income is the ability to pay, and it indeed can create an endogeneity problem with property prices, but at the area level, so if you take the area level income, for example, at the LSOA level, that can represent a proxy for socioeconomic factors, like which is an utility-bearing component, or proxy for unobserved area quality, in case you haven't measured every characteristic. For example, how beautiful the streets are around the property, which is very difficult to measure. So we think it does have a role in models beyond endogeneity problem. It is area income, and additionally, it's also a factor that influences the value of the other components. So in other non-market valuation techniques, as you all know, like stated choice experiments, so for example, valuation of time studies is just commonplace to include income as a driver of values, but that's not really often done in hedonic prices. So we thought income does have a place as an interaction term with the key components of key value drivers. Fourth, and finally, what is the role of the prices of the neighboring properties? And that's key in the context of these new spatial models being applied to hedonic pricing, mainly the spatial lag and the spatial error models that includes the price weighted average of the prices nearby as an explanatory variable. Well, this is one of the main reasons given to justify spatial lag model is that the sales comparison approach, that's based on a paper by Small and Stamets, where they say, right, it can be justified under certain strong assumptions, mainly, for instance, the main argument they give is, right, if when state agencies or people assess the price of a property, they look at prices nearby, sales comparison, then that obviously is a factor affecting prices. However, in real life, yes, that does happen, but I also presume that happens because people don't have a hedonic price model at hand to check all the characteristics and try to derive the value. So if we do that theoretically, and we have a model where we control for all these factors, maybe we don't really need that sort of assumption of the sale comparison approach. Second argument is that there are some spillover effects, but you need to define those. And it's not very clear how to do that. I won't go into the details yet. And third, again, as a proxy for unobserved factors in the area quality. So that is similar to the income effects in that sense. So that's something we would like to test, whether you can have both in the model or whether one is actually or both are picking up the same thing. Right, so with all of this, right, final point also is important to look at the relationship between the variable that you're interested and some of the other explanatory variables. In the property market, is really complex. We cannot deny there are relationships in there between income and education and so on. Some may be not relevant for your purpose, but some may be. In our case, it turned out that access to jobs using some well-defined metric of accessibility, using gravity function and so on, in line with the ones we saw yesterday from Jerome or Karst. There was actually some relationship between the variable that we had about accessing a town center. Because we wanted to measure the value of a town center as a sort of social space, community space, but the definition that we were given, we took it from the DFT, it was strongly related to jobs. So obviously that interfered with our well-defined accessibility measure. So, okay, so then how do we go around from the theory to model specification? We can start with the basic model and just say OLS, but that can be others as well. We say we have all these different categories in there, which a lot of variables in more detail that we'll get to see in a minute. We look at having an income term as well, which we think is a utility-bearing factor, proxy for area quality and so on. We include income interaction with key valuation items to generate distributions of these values. Then we also test for the spatial lag model, which basically adds the weighted average price of neighboring properties into the model, and for the spatial error term, which does a similar thing but into the error part of the equation.
Sorry, inc bar is average income? Average
income, yeah, sorry. Yeah. So, a little bit about the data set. So a bit about the data set. There is a regional data set. It includes all property transactions in 2016 in the whole north of England, which is over 160,000 observations. It's a cross-sectional data set. And it has a quite comprehensive coverage of explanatory variables, well defined. So for instance, accessibility, we define it using the best data that we could find, the best fitting the gravity, the decay function to the census data, and so on, and for different modes, for rail, car, and walk. High spatial resolution for all of the key variables. This is just a map showing you what the area that it covers, all of the north of England. Gravity model, the best that we could fit. Again, completely agree with what Carl said yesterday. The way you define it can play a massive role in the model. But we did some tests initially. It is very time consuming, so we did the best we could theoretically and empirically. And our generalized German time, for instance, includes aspects that probably not included in many variables, in many accessibility indicators like crowding, reliability, frequency, and so on. So it's not just time. and it's fitted to the census data both for rail, walk and car. And at the output area levels is very, very localized. It's nearly from the house to where the jobs actually are. So with all of that, now we go on to test this. There are some papers out there, a lot of papers looking at comparison between OLS, SAR, SEM, and so on. So we do that with our regional data set and adding this also models with the income interactions, both for OLS and for SAR. So I just want to discuss a little bit of the result and what we find there. So in terms of model fit, it's not surprising we get, as all of the papers, spatial models perform better than OLS, fine. But OLS actually doesn't perform that bad. We'll see that in the estimates now. The question is how different, if we have to use this model for policy purposes, how different are the estimates here? Significance, magnitude? I mean, previous papers made decisions on which model to recommend based not only on model fit, but also which variables they were actually able to estimate significantly and with the right sign and so on. Surprisingly, I was quite surprised when we started running even basic models with OLS. Straight away, significant coefficients, correct sign for everything. It was like, okay, I had experience before with working with more standard HP dataset at one city, and I thought maybe this has to do with this wider scale of having a regional dataset. I don't know. Anyway, so this is what we find. It's really messy, not expecting you to understand all of this now, but so I have here there on the top, I have 3 columns for OLS, SAR, and SEM. The SAR model is the combination of, if you're familiar with that, you have the direct and indirect effects, so that's already the combination. I'm not saying that it's necessarily the impact, as you know, it's not clear when you should add the indirect effect or not, but for purpose of comparison and clarity here, that's the combination of direct and indirect for all of the variables. And there's a model, and we don't see, first of all, we see that all of the variables, all of the key variables have the expected sign and have good level of statistical significance in all cases. And the difference between models are not massive. I mean, considering what I've seen in other papers, it's not really a big thing. You do get some interesting ranges depending on the variable. But the differences are not something we cannot really deal with in plain terms. So this model goes on, there are more variables, I haven't put them all. So we also get valuation estimates that significantly vary in the expected way with income. So for instance, better rail accessibility increase property prices, but it does so to a larger extent in richer areas, which was our initial hypothesis. The same for school, primary school, secondary school quality, access to a town center defined in a different way through access to banks as a proxy, because to avoid the issue with the jobs. Parks, playgrounds. In all of the cases, we see that the value of the amenity or attribute is higher in higher income areas, which is an interesting addition to explain valuation here. But we do see, this is one of the things we were suspecting, that under the SAR specification, then the income effects, we also had it as non-linear there, it becomes negative in some cases, which only happens in that case. And that suggests indeed that actually in a well-specified model with a comprehensive data set, it is possible that the income effect, that on the grounds that is picking up area quality and so on, is confounding with the price of the nearby properties. And you may have to choose which of those specifications is better for you in the model. So, just to give a bit more insight in the empirics part of the, forgetting a little bit now about the actual deviating, just to show some of the interesting stuff of the work. What we find in rail accessibility is that we find an average premium between 12 and 14% for properties in the most rail accessible location, which basically is properties that see nearly 1 million jobs discounted, relative to properties that see nearly 0. That's this 12-14% premium. but the premium is much higher in areas, more affluent areas, and lower in lower income areas, suggesting that rail investments may have different impacts on the property market depending on where you place them. And that can be important for if you are going to design land value capture mechanism, distribution analysis, and so on. So this is what we get. So a bit of key points that we get from this model comparison. First, that we see significant and correct sign of fault coefficient, which isn't necessarily easy in the literature. The differences are not unsurmountable. We find papers indeed where moving from an OLS to a SAR to a SEM changes even the sign of some coefficients. Here we don't have any of that for all of the key variables. There's one exception that I'll talk about in a minute. But as I say, there's some choices to be made, as there could be some confounding going on. So income interaction indeed help a lot to unpack heterogeneity in the values in a way actually that can be useful for policy and directly applied, just like with other non-market valuation techniques. Again, reveal this potential confounding, which I think we have to think really carefully about what is the economic rationale for having the price of the neighbors in the model as is currently being done under the spatial lag models and spatial error models. I don't think we've got to the bottom of that question yet, and I think it's really important to think about that. So parks and playgrounds were the only problematic ones where we were seeing no significant values or even negative, but we suspected that was because they were defined again as a potentiality indicator, so access to parks nearby some playgrounds. But obviously that doesn't include quality. There are good parks and there are not so good parks. So when we interacted the variables with income, we picked that up. Basically, some of the areas, in the better areas, parks do have a great value. In not so affluent areas, parks could even have a negative value. Potential reasons, maybe safety perception, lack of quality of the space, we don't know. But indeed, through the income interaction, we were able to still generate that effect in all of the models. So, question is, which model do we recommend in this case to apply? Because Transport for the North want to apply this to look at the business cases for, in this case, a really large project. I'm not sure if you heard of the Northern Rail Powerhouse, linking together all the northern cities, Leeds, Manchester, Newcastle, shortening significantly travel time. Yeah. More critically, from an academic perspective, what are the assumptions and implications of each of these models? Because we still see a superiority of spatial models, we have no question about that, we don't deny. But in this case, all of the models are able to recover significant estimates. And which ones? What are the assumptions here? So obviously, OLS, you can value the goods directly, you have the standard econometric issues, some may say. But then, whereas in the SAR model, main intuition is you have this explanatory power of your variables splits into two direct and indirect effects, and I would argue it hasn't yet been fully understood where those indirect effects come through and when they don't, and so you need to decide whether they're what they call technological, which in this case they will affect welfare calculation, or pecuniary, in which case they won't. So there's some decisions to be made, even though the model fit is superior. But additionally, it suggests that the actual additional term of a SAR model can be picking up something that is already being picked up in a more parsimonious model by income effects. So again, another decision to make. With regard to the spatial error model, we think that what's happening there is that we see a lot of reduced significance and magnitude of the coefficients. And by intuition, what the model is saying is that if you have the prices of the properties nearby, and you put them into the error, you're sort of saying, right, that's something you have to control for, but they are not part of the value of this accessibility, school quality, and so on, which I personally do not agree with the intuition, but again, it's a model that is widely used, so it's just good to have that discussion. And overall, we have this suggested way of accounting for income interactions in a way that you still derive your global estimates for values, but it allows you to have more localized valuation estimate in a way that is directly usable for policymakers. So that's it. Conclusions, I already repeated all of this. I'm not going to go through that again. So thank you very much.
Thank you. Thank you very much, Manuel. The floor is open for discussion. Questions? Last? And then
I was wondering if you have looked at, let's say, the difference in the pricing model between using cross-section data and repeated sales, because there have been some studies in the Netherlands, and where, let's say, the cross-section donor prices seem to have a very high correlation, for example, between station openings, and then the repeated sales method found actually zero correlation. So I think looking at this from a panel, let's say, a perspective, doing before and after, let's say, looking at the changes in accessibility or additions in a transport network versus, yeah, I mean, in a cross-section method, you have so many unserved factors which are sort of, yeah, in a way correlated in a model that I have usually very strong doubts on, let's say, cross-section pricing models, but maybe you found, let's say, different results. I was wondering if you also try to do that.
Yeah. Okay, so yeah, the answer is yes, we did. So we, as part of this wider project, we also developed a time series model, panel data. It wasn't repeat sales data, but it was time series looking at a specific series of accessibility improvements in the area of Manchester. And then we sort of look at the numbers from the time series and the cross-sectional model for the area, and actually they're not that different, which was reassuring. But yeah, I agree. It's a different approach. The problem with time series or repeat sales data is that normally defining all of the variables to the level that we have done here, spatially detail level, is not possible because you don't have data going back in time. Especially for accessibility indicators, we don't really have good data defining accessibility indicators going backwards, because at least not to be able to do it in the way that we've done it here, where we have access for rail, car, and walk all together. And also the way I see it, I completely agree with the concerns, and I was also skeptical. Always, right? Okay, it's a cross-sectional model. But at the end of the day, you're just looking at slice of time, and when anybody enters the property market, you're making that decision. You know more or less, the variables are relatively stable, so you know more or less what you can access from that location, what's the quality of the environment, you know, you have an idea. So kind of underlying assumption that you trust that at the given, if you have a large enough data set with lots of different combinations of location, which we do because it's so many cities together and in between rural areas, it's a very large regional area, you have this massive amount of combinations of property characteristics. And I think it's the fact that we do find correct sign for every variable that we think it should have a role in the overall value of the property. That's, I think, reassuring that this.
One last quick question.
Yes, I'm not sure I understood the motivation for the introduction of this spatial effect, the theory behind that. And just very briefly, in the past, in the economic field, people used to do regression, growth regression, trying to explain the growth income against the growth of labor and capital. Then at some point with the development of spatial econometric, people start, for whatever reason, start to run regression SAR and SEM, but without any theoretical motivation. Then, after 1 decade or so, people start to say, why don't we introduce a technological spillover effect in the production function? We derive a steady state, and then they show that they end up with an equilibrium with the spatial Darby model, which is something that includes both the SAR and the SEM.
Yeah.
So the question, maybe it's not fully clear, but the question is, I don't clearly see the theory, the reason, the theoretical reason for the introduction of spillover effect in your case. I mean, why you need to introduce SAR, SEM, or spatial Darby model?
Well, I'm glad you mentioned because I also don't see it fully. That's the point of this. The problem is that there are a lot of people doing it now in the hedonic pricing context, and I'm not saying so. The spatial econometrics field is huge, and there are a lot of different applications which I'm not questioning. But for this particular case, I'm also of the view that that figure, if you have a well-specified model and you capture area quality effects in ways with variables that are easily measurable for policy, you don't need that. I personally don't see that link of having the price of my properties being influenced. If you improve rail accessibility, it's going to influence the price of the neighbors, and that's going to influence me. I don't see the need for that triangulation in a way. So I agree with you. It's what people are doing, and some of the papers are actually doing in a very, as you say, with a real justification and systematic way. And I'm a bit concerned that obviously you get better models here.
Could we just summarize your position by saying stick to the OLS?
Stick to them with good data.
With good data.
Yeah.
Get good data, stick to the OLS.
Just on this, the introduction of this spillover effect, one justification could be, I can have a perfect model with perfect data, but I am never sure that I have all the variables in my model. So it's there to say, okay, and just to be sure that if there is something that I don't have in the model, at least to estimate it.
This is why you have the